All right, so before we get started with the strategy pattern, let me bring up the diagram, the typical class diagram that shows that typically shows what this uh, design pattern looks like. So here we have the typical design pattern class diagram for the strategy pattern. We have a context, which is kind of represented by our payment processor. We have an interface that represents the strategy, and we're going to show that shortly. And we have these two concrete implementations, in this case, of the strategy. This is sort of a representation of what we're going to build shortly. So let's start with our interface. So what we want to do with the strategy patterns, we want to leverage, instead of inheritance, we want to leverage composition. And to get started there, we'll create an interface called iStrategy validate, and call this iValidate instance variable. And we need to create this interface, so we'll use Visual Studio's Quick Fix. Now we have our iStrategy validate, and so we're going to start by adding a validate method here, and then we want to have concrete implementations of the validate method. And those concrete implementations will extend or implement this validate interface. What we're not doing is we're not going to use the concrete classes to extend this interface, but we'll create concrete implementations of this interface. So the first one we'll create is strategy validate CVV implementation. And that'll be a class, and this is going to implement the iStrategy validate. And we want to implement the validate method here, so we're going to return a string for validate that says validating using the CVV algorithm, or algorithm strategy slash behavior. Remember, this is a behavior pattern, and so behavior, strategy, and algorithm all are kind of synonymous. All right, and so next thing we'll do is we'll create another implementation. Strategy validate no implementation. Remember, because PayPal doesn't really use CVV, so, and we don't know what PayPal uses. So for now, we'll just create a no implementation. So we'll be implements iStrategy and public string validate, and we'll return here. Currently, don't do CVV, or maybe don't do validation. All right, so those are our concrete implementations of the iStrategy validate interface. Now, to use those implementations, what we want to do is take the concrete classes and basically default the strategy to one of those concrete implementations. So, and now because we have also these classes extending payment processor, remember we have access. Let me save this and close this down. We have access to the this iValidate instance variable, right? So we can go back into the concrete implementation for these payment processors and assign iValidate to a concrete implementation of the strategy. that is of interest. So in this case, for credit, we want to associate or default the strategy to CVV for validation. And for PayPal, we want to use the no implementation for PayPal. Okay, so now we have our concrete classes defaulting the strategy that they're going to leverage for validation. And then now we're not using it yet in the payment processor because we're still relying on this method to print the validation approach here. So to fix that, we're simply going to delegate the iValidate strategy to the concrete implementations for the subclasses. And we do that simply by just saying validate. So remember, this is going to be assigned to one of the implementations based on the subtypes, the processor subtypes. And then when this is called, that call will be delegated to the default implementation or strategy that's defined in these subclasses. All right, so let me save everything and let's run this again. So if I start with credit, I now get validating using the CVV algorithm, strategy or behavior. And if I try PayPal, PayPal currently doesn't do any validation. So if I go back here to the API, you'll see that we didn't have to change in any of this code. These concrete implementations of processors are instantiating default behavior for validation. And when we call the validate method, ultimately that's going to get delegated down to these subclasses. That kind of almost wraps up the strategy pattern. The last thing we'll do with this is show, how do we take advantage of this solution to be as flexible as possible in allowing us to make a decision at runtime. And then we'll wrap things up with doing one final set of refactoring to move this code into a service.